Okay, so today we're going to look at advanced inertial sensor. All right, let's have a look at how we use the inertial sensor. So last week we looked at how to use the inertial sensor blocks here. And let's try to understand all the different ways that we can use these sensors. Okay, so calibrate brain inertial. What this does is that it makes it so that your robot resets the position of the sensor. And it's really important that because this is the inbuilt sensor of the VEX brain, we'll install later, of the VEX brain, that the brain is mounted in a very secure way on your robot. Don't let it flop around. Don't let it move about when your robot is moving. That's really important. Okay, so when you calibrate your sensor and you run this block, your robot has to be absolutely still. It has to be absolutely still. You can't do it in a car. You can't do it in a plane. And you definitely can't do it when you are holding the robot. Your calibration will take maybe 5 to 10 seconds when your robot is completely still before it is able to fully calibrate. Okay, so make sure that if you run this, you only do it when you are not in a match, so that the robot only runs it when it is completely still, when it's debugging. So to actually access it, we should go brain inertial dot calibrate. Okay, so this is the same block as the brain. This is the same command as calibrate brain inertial. Okay, I'll do it like this. What about setting brain inertial heading? A lot of people get confused about these two. Okay, heading and rotation. Now, heading is an absolute value. Okay, when you start your robot, your heading is at 0. That's the way that it is currently facing, and it is an absolute position, whereas the rotation is a relative position. So I can spin heading from 0 degrees all the way to 360 degrees or 359 degrees. But for brain inertial, it can go all the way up to infinity. Okay, if you keep on spinning clockwise with your robot, the rotational degrees will keep on increasing forever. And then if you decrease it, if you spin the opposite direction, it'll go to the negative degrees. Whereas heading is always absolute. There are only 360 degrees for the heading, and then your robot, when it is facing those compass points, then that's what this is. Okay. Now, when we are using our robot for competition, and we were coding it last week for PID, we use rotation. Why do we use rotation? It's because sometimes you may need to rotate an obtuse angle. All right, you might not need to snap to a closer angle. All right, you might want to rotate your robot in a reflex angle. Okay, in which case you can just increase the rotation or decrease the rotation to the negative side, and it's not going to change the way you're looking. Another benefit of rotation is that it works really well with PID, because your headings are going to snap between like 0 degrees and say 270 degrees, right? It goes 0, and then the next degree over to the left is 359 degrees. So when you use rotation, you're not going to have these snapping distances. Okay. So when you set the brain inertial heading, that's just a quick way to set the number so that wherever you're pointing right now, that is facing this degree. So to set your brain heading, your brain inertial heading, we go brain inertial dot, and then we can say set heading value. It can go 0 degrees. Okay. What about your rotation? Well, you just go brain inertial dot set rotation to 0 degrees. Okay, it's as simple as that. Very useful stuff. All right, let's have a look at the next one. We got heading in degrees. So heading in degrees and rotation in degrees, these are reporters that we're going to get back. We can use these reporter blocks to get those exact same things. So brain inertial dot get heading. Oh, hold on. We'll just go heading. Okay. And brain inertial dot rotation. So these two are now are equivalent to these two. You see how, because of switch blocks, it's just so easy now to code in Python. It's really, really quite awesome. What about acceleration x, y, and z in G's? Wow, that's cool. That's in gravity units. And then we can also get the gyro rate in degrees per second. And also the orientation of the pitch roller yaw. So, to get brain inertial acceleration, we just go brain inertial dot acceleration, and then we can put in your x-axis like that. And then you do y-axis and z-axis using the same notation. What about get gyro rate in degrees per second? We can do that with another reporter and the reporter switch block. Brain inertial dot gyro rate x-axis comma, and then we got degrees per second. This is great. Code completion is just so cool, right? What else do we have? Rotation and heading in degrees. I'm pretty sure we've done this before. Oh yes, we have done it before. We did that just before. Oh, what about this yaw angle in degrees? So, brain, oops. I always keep pressing enter premature. Brain inertial dot orientation. And then we can go pitch, roll, or yaw. So yaw in degrees. Now you may be thinking, why there are no other units when we go degrees? Why can't we use radians? Well, because nobody uses radians. But if you did want to use radians, you would make it yourself, right? You would use a function or a little bit of math, just and do your own radians. But they might add it in the future. All right, so that's the in-depth of all the inertial sensor blocks and how to access them all using Python in switch blocks. What about if we that's it. That's all there is to it. It's not too hard, but finding use cases is hard. Finding use cases for everything. You need to understand all your functionality, and when it becomes useful, it's useful. But when it's not, it's just good to know. Okay, I hope everybody had fun in today's Python class. I know it's a little bit short, but if you have any questions or suggestions on how we can run the next class, feel free to send us a comment or a message. I'll see you next time. Bye-bye.